Right, in this video, I'm going to be working AP Calculus Homework 4.2, linear approximation. And so we're going to be writing a lot of tangent lines, plugging in a lot of x's. And so we will start using a linear approximation to estimate the values of f of 3.1 and f of 2.99. And we have information about f at x equals 3, so that's probably where we're going to need to put our tangent line. Yeah. All right, so I've got a point, slope. I'll write the equation. Got a lot of practice on that already. And then we're interested in f of 3.1 and f of 2.99. Okay, so f of 3.1 is what I would get if what y would be if I plugged in x equals whatever, right there. So I'm going to just start by saying, okay, well, f of 3.1 is going to be approximately equal to, I'll add the 4 to both sides, minus 2 times 3.1 minus 3. And, on the quiz, for your response, you can stop there, but these are very frequently multiple choice questions, so I'm going to keep going. Minus 2 times 0.1, 4 minus 0.2 would be 3.8. All right, and then I'm going to also need f of 2.9. Okay, so an approximation for f of 2.9 would be 4 minus 2 times 2.9 minus 3. So that'd be 4 minus 2 times negative 0.1. Okay, so 4 plus 0.2, that would be 4.2. Right. The linear approximation for g at x equals 2 is y plus 3 is 5 times x minus 2. Pardon me, I must have misspoke. I think I meant y minus 3 equals 5 times x minus 2. I forgot that was a change I was going to make. Okay, so what are the values of g of 2 and g prime of 2? And so I'm going to say, all right, well, I could get g of 2 out of the point slope form from there, right? So g of 2 is going to equal 3. And I could get g prime of 2, that would be the slope of the tangent line, that would be right there. So g prime of 2 equals 5. Now the first run of these that I printed, I had y plus 3, but I have decided based on part B that it would make a lot more sense if I had y minus 3. So that's what I'm going to be changing it to for future iterations of this homework. Okay, so what are the values of g of 2 and g prime of 2? We've got them. If g of 1.9 equals e, and g has no points of inflection, is g double prime of 2 positive or negative? Okay, so it's asking about the concavity. It's telling me the true value of g of 1.9 is e. So what I should do is get the approximated value from the tangent line. So what I'm going to say is g of 1.9 from the tangent line would be 3 plus 5 times 1.9 minus 2. So that would be 3 minus 0.5. And that would be 2.5. Okay, but the true value of g is e. Okay, so that means that the true value is greater than the approximation. And if you've got it memorized right now, good for you, but that probably won't last for very long. So what I'm going to do is say, okay, well, I know that the slope is 5, and that's a pretty steep positive slope, so I'm going to draw the tangent here. Okay, and maybe that's the point of tangency, and I'm trying to figure out whether the curve sits above or below the line, which is going to determine the concavity. So I'm just going to say, all right, well, this is the point of tangency. This is 2 and 3. At x equals 1.9, on the line, I determined that was 2.5. Okay, but we found that the actual point on the graph was 1.9 and e. Well, e is like 2.7 or something, and it's greater than 2.5 and less than 3. So I'm going to say that's the point 1.9 and e. So, this is obviously not drawn to scale, but we're going to be having to have something about like that happening. Okay, so the graph is going to be concave up. G double prime of 2 is going to be greater than 0. It's going to be positive. Okay, now the next one here shows us a graph of f prime. Okay, not the graph of f. It is known that f of 1 is equal to 4. Use the linear approximation to estimate the value of f of 0.8. Okay, so I'm going to need a tangent line. Let's say the point is going to be f of 1 equals 4, so 1 and 4. The slope, I'm going to go over here, looking for f prime of 1. Looks like f prime of 1 equals 2. That's really all the information we're supposed to get off the graph. Oh, nope, it's not. I see that in part B, we're going to be interested in the slope of f prime. All right, so f prime of 1 equals 2, so the slope would be 2. I'm going to write down the equation. And then I can do the approximation. So that would be y equaling 4 plus 2 times 0.8 minus 1. That's 4 plus 2 times negative 0.2. So that would be subtracting 0.4, that's 3.6. Right, so f of 0.8 is approximately 3.6. Okay, and then for part B, is my value an underestimate or an overestimate? I'm going to, and justify my answer, okay, I'm going to be thinking about the concavity of f. Okay, well, f prime is increasing. Okay, and it looks like it's increasing for all x. I don't really know that. What I need is I need for it to be increasing between the point where I'm tangent and the approximation point. So that would be between 0.8 and 1. Okay, and so that means the graph of f is concave up, or probably better yet, f prime of x is greater than 0. For 0.8 to 1. Okay, and since the graph of f is concave down, we know that a tangent line is going to sit over the curve, and it'll be an overestimate. Right. Now the next one, we've got h of x equals 1 plus tangent x to the 3/2 power. Okay, we're an equation for the line tangent to the graph of y equals h of x and x equals 0. Okay, so we're going to need to figure out what is h of 0. So 1 plus tangent of 0 to the 3/2, any power of 1 is going to be 1. Then, what is the estimate for h of 0.2? Oh, I didn't write the equation for the tangent line. I tried to find h of 0. I was happy with that. So I'm going to need h prime of x. I'm not going to be ready to start part B down there, I don't think. So 3/2, I'm going to use the chain rule, right? On the outside, subtract 1. Leave the inside the same. And then multiply by the derivative of the inside for the chain rule. Alright, so I'm going to need h prime of 0. That would be 3/2 times, again, 1 plus 0 to the 1/2 power times secant of 0 squared. Okay, well, secant 0 is 1 over cosine 0. We know cosine 0 is 1. So this is just going to be another 1. And this is going to equal 3/2. Okay, so I'm still not ready. I have that written there. Makes me want to move on to part B. Okay, so my equation would be y minus 1 equals 3/2 of x minus 0. And then I'm ready to estimate h of 0.2. 1 plus 3/2 of 0.2 minus 0. Okay, 3/2 of 0.2 would be 0.3. That would be 1.3. Okay, the true value of h of 0.2, rounded to 3 decimal places, is 1.319. Is h double prime positive or negative on the interval 0 to 0.2? And there's not going to be any points of inflection in there, trust me. It's not going to happen. So we're going to say, okay, based on the fact that, no, so the real value is greater than the approximate value, that's going to be concave up. Yeah. Regardless of if we're approximating to the left or to the right of the tangency point. All right, so I'm going to say is h double prime is going to be positive. Because the linear approximation was an underestimate. All right. Next, we've got another table one. And these are always nice. Okay, so write an equation for the line tangent to the graph of f at x equals 3. All right. Y minus -1 is equal to 4 times x minus 3. F of 3.003 would be approximately equal to -1 plus 4 times 0.003. Okay, so that'll be -1, whoops, plus 0.012. And, if you want to add that, you can. I just don't think that's going to be necessary because part C is going to ask which is greater, the value or the approximation. And we're going to say, okay, assuming f double prime doesn't change signs, no point of inflection on the interval 0 to 0 or 3 to 3.003. Okay, you got to be careful with the which is greater question. Okay, I'm going to just draw the picture. Okay, f double prime is negative, so the function's increasing and concave down. Kind of drawing the tangent line that was really not very good. And there. And say, all right, well, the tangent line is going to overestimate, so the greater one would be the approximation. Okay, so the approximation is greater. Okay, number 6. G is going to be a solution to the differential equation dy dx equals y plus 1 times x minus 3 with g of 1 equals -5. Okay, I can write an equation for a tangent line. So the point will be 1 and -5. Slope, I'm going to have to do a little bit of calculation. Dy dx at 1 and -5 would be, all right, y plus 1, x minus 3. Yes, that's going to be 8. Okay, and then we're going to use the tangent line to approximate g of 0.9. So, y equals -5 plus 8 times 0.9 minus 1, which would be -5 plus 8 times -0.1. So 5 minus 0.8 is 5.8. All right, just like that. And then it is known that g of 0.9, the true value, rounded to 3 decimal places, is negative 5.910. Based on this information, is it more likely that g of x is concave up or concave down on the interval 0.9 to 1? And explain. Okay, well, it's going to have to do with whether I had an overestimate or an underestimate. Okay, my estimate was negative 5.8. And this is, oh yeah, I'm glad I put this on here. Okay, versus negative 5.9. Okay, negative 5.8 is greater. Okay, so it was an overestimate. So I'm going to say the linear approximation was an overestimate. Okay, so if the linear approximation is an overestimate, that means that it's more likely that the graph is concave down, right? And if there are no points of inflection between the tangency point and the approximation point, it will be a guarantee that the graph is concave down the whole time. So I'm just going to be bold and go ahead and say g is concave down on the interval 0.9 to 1. We were off by so little, that would, well, I guess that would also happen if you had a point of inflection in there, I guess. Okay, speaking absolutes on that. So next we've got this implicit curve. Point Q is on the curve, and the y-coordinate of point Q is 1.03. Okay, yeah, so Q is the point on the right, and the point on the left is 1 and 1. Which 1 plus 1 is 2, 5 minus 3 is 2. Yeah, that does make sense. Okay, first find dy dx. Okay, so I'm going to take the derivative of both sides of that equation, just like we did last time. 4x to the third plus 4y to the third dy dx equals 10x minus 6y dy dx. Alright, so I'm going to collect everything that has a dy dx over to the left-hand side of the equation. And get rid of everything that doesn't have a dy dx to the other side. Factor out the dy dx. And then solve for dy dx. Alright, great. And then we're going to write an equation for the line tangent to the curve at the point 1, 1. Okay, I'm going to need the slope. So I'll use the slope formula. And so that would be 10 minus 4 over 6 plus 4. So I got 6 over 10 is 3/5. Wait, I feel like I've done something wrong here. Oh yes, that was it. I think my mistake was that it wasn't Q, y coordinate of Q being 1.05. I think that was what I needed. So writing an equation, that's not going to keep me from writing an equation, but that was what seemed wrong about it, was I was thinking about the approximation and that I'm going to need the distance to be, divisible by 5. So I'm going to say my equation is y minus 1 is the slope times x minus 1. Okay. Now, and this is nice because I'd been interested in this type of problem, making sure I had one of these on the homework, was, finding the x coordinate of Q. Okay, we're used to approximating a y coordinate, right? An output value of a function using a linear approximation, but we could use this on an implicit curve to approximate an x coordinate as well if we needed to. So what I'm going to say is estimate the x coordinate of Q. I'm going to plug in the y coordinate of Q. 1.05. No, I just outsmarted myself. Pardon me. I did want that to be 1.03. I see exactly what's going on. I should have trusted myself. Remember, there was something kind of subtle about this question. 1.03 minus 1 equals 3/5 of x minus 1. Okay. So I'm going to do the subtraction first. 0.03 equals 3/5 of x minus 1. Okay. And then I'm going to not divide both sides by 5. I'm going to divide both sides by 3 and multiply by 5. Or however you want to do that, and get it figured out. But either way, that's going to be 0.05 equals x minus 1. And so I'm going to say x is approximately equal to 1.05. Pardon me, I made this homework not that long ago, but it was long enough for me to forget about what was actually going on in this question. All right, so we're going to just keep moving. The graph of f passes through the point 3,1 and is concave down. That's an error. Yeah, I definitely meant 1, 3 on that one. Okay, so yes, use a tangent line to approximate f of 1.2. All right, so y minus 3 is equal to the slope times x minus 1. I'll figure out the slope at the point 1 and 3. And that'll be 3 squared is 9 minus 1, which is 8. All right, and then f of 1.2 is going to be approximately equal to 3 plus 8 times 0.2. 8 times 0.2 would be 1.6, so my estimate is 4.6. All right, and determine if that's an over approximation or an under approximation. Based on the fact that they told me the graph is concave down, it's got a very positive slope, I'm going to say, okay, well, the tangent line is sitting above the curve, so that's going to be an over approximation. I don't think that's language we typically see very often, but I just wanted to include it just in case. Okay. What is the approximation of g of 5.8 using the line tangent to the graph of g at x equals 6? All right, well, g of 6 equals 4, so y minus 4 is equal to the slope times x minus 6. Go off to the side and compute the slope. And have 2y over x. And then g of 5.8 is going to be approximately equal to 4 plus 3 times negative 0.2. 4 minus 0.6 would be 3.4. All right. For the function h prime is this. What's the approximation? Okay, so I just figured I'd put a couple of easy ones at the end, just in case you needed any more practice. Okay, but hopefully, maybe by this point, you're already feeling pretty good about this. Y minus 2 is equal to, well, I need h prime of 5. That's going to be 10 minus 3. So that would be 7 times x minus 5. H of 5.001 would be approximately equal to 2 plus 7 times 0.001, and so that would be 2.007. And yep, that's going to be all the problems, so that's all for this video. Thanks for watching.